All right, folks. So now we're going to be talking about how do we calculate frictional force. All right. So what do we need to know in order to calculate frictional force? You might have seen this little symbol in the last section. It's the Greek letter mu. It looks like a lot like a U, but it's got something hanging off the front. But this is how we would calculate. The force of static friction is FF, and then you put a little S there to just indicate that it's static friction, is equal to this mu S times the normal force. Okay? And then the kinetic friction is the same thing, except there's a K in front of it. All right, so the coefficient of friction is basically just kind of a description of what the surface is like. The rougher the surface, the higher the value of the coefficient of friction. The smoother it is, the smaller it is. Ice has a coefficient of friction very close to zero because there's very little friction. Okay, and as before, there's two types. There's the coefficient of static friction and the coefficient of kinetic friction. Right? And remember that the only way that we change the coefficient of friction is to change the surfaces. So if I put another box on the same surface, the coefficient of friction is going to be the same. If I put more weight in a box, the coefficient of friction is going to be the same. Okay? Changing the weight, therefore the normal force changes the friction. It does not change the coefficient of friction. Right? It just changes the normal force and therefore the frictional force, not the coefficient of friction. All right, so let's look at another example here. What is the static friction force for a 30 kilogram mass on a horizontal surface? And the coefficient of static friction is 0.525. All right, this would be the force that I would need to be able to push at to get something to move. All right, so the force of static friction is equal to mu times the normal force. Mu is 0.525. The normal force, all right, let's draw a free body diagram. Fg, Fn. So we know that Fn is going to equal to Fg, or not Fg, sorry, Fw, which is m times g, or 30 times 9.8. 30 times 9.8, 294. So it's going to be 0.525 times 294, not 2.94, 294. 525. So the frictional force would be 154.4 newtons. Right? If it's a smoother surface, then this number is smaller, so this number will be smaller. If this was a heavier box, the weight would be heavier, the normal force would be greater, therefore the friction would be greater. So if I push that same 30 kilogram object with a force of 100 newtons, what acceleration does the object experience while it's moving? So let's draw a free body diagram. Again, weight and normal force are equal. Fw, Fn. I'm pushing it with 100 newtons of force, so this is my applied force. F applied equals 100 newtons. And then this is going to be since it's moving, this is my kinetic frictional force. Right, this is going to be FFK, which I'm going to need to calculate because I have a different value. Right? So net force is equal to MA, and we're looking for A. So the net force is going to be the sum of my forces, which is going to be FA minus FF equals MA. Well, we need to figure out what the force of kinetic friction is. Right? That's equal to mu times the normal force. Mu is 0.325, and the normal force is going to be 30 times 9.8, which we already calculated. Right? So we find out that the total frictional force is 30 times 9.8 times 0.325, or 95.55. So it's going to be 100 minus 95.55 is equal to 30 times A. 95.55. That's 4.45 is equal to 30 times A. Divide both sides by 30. And we get 0.148 meters per second squared. Oops. All right, notice again, same process every single time. And then for example 6, we just want to say, going back to example 3, I want you to determine the coefficient of friction. Well, in example 3, we determined that the force of friction was 20. So we know that the force of friction, and I don't remember what it was. I'm going to go back real fast. Example 3, it was sliding, so this would be kinetic friction. All right, so this would be the force of kinetic friction, FFK, is equal to mu K times the normal force. Oh, got to go back one more time, because what's the normal force? What was the weight? It was a 40 kilogram crate, so we're going to go back there. So we're going to go back over here. Whoops. And so we know that the mass was 40 kilograms. Therefore, the weight, which is the same thing as the normal force in this situation, is going to be equal to 40 times 9.8. 40 times 9.8. That's going to be 392 newtons. So force of friction is 20. That's going to equal to mu times 392. And to solve for mu, we divide both sides by 392. So 20 divided by 392 gives me a coefficient of friction of 0.051. Right? What are the units of mu? Well, when I solve for mu, I'm dividing a force divided by a force. So it's going to be newtons divided by newtons. So they cancel out. There are no units for coefficient of friction. It's just a number. All right, so we're going to have one last thing we'll talk about. We'll probably do that on Monday, and that is how do we look at the forces when they are on an incline. We're not going to do any calculations with that. We're just going to be able to we're going to talk about drawing a free body diagram. But I think we'll talk about that maybe on either Friday or Monday.